Okay, so on question number 6, you were given that log base x of 3 is equal to b, log base x of 2 is equal to a. And you have to use your log laws in order to write log x of 9 in terms of a and b. So first of all, when the question says in terms of a and b, it means that your answer has to have either a's and b's. It can have numbers in front. It might be this. It might be something else. But that's what in terms of a and b would be. So we know that a is equal to log x of 2, and we know that b is equal to log x of 3. So our job is to think, how can we rewrite log x of 9 using only log x's of 3 and log x's of 2? Or maybe it's just one of them. So first of all, I'd probably say, well, I know log laws for multiplying, dividing, and if there's a power inside. So I'm going to see if I can rewrite 9 using only 3's and 2's and exponents. So there's a couple ways you could do that. You could say 9 is 3 times 3. And then you have multiplication inside of your log, which means that you could expand it as log x of 3 plus log x of 3. If you do that, well, log x of 3 is b, and log x of 3 is b, so the answer in terms of a and b is just 2b. Did anyone do log x of 9 as 3 squared? That would work as well. What exponent rule, what log rule can you do with that exponent? You could bring that out in front. And since log x of 3 is b, you'd get 2b that way as well. So part B, we have log x of 6. Any ideas on how you could rewrite 6 using 2's and 3's? Sorry?
Log x3 plus log x2.
So are you saying that's, are you doing this first, right?
Oh, yeah, sorry. Yeah.
That 6 is 3 times 2? And then you can go log x3 plus log x2. And this is b, and this is a. So in terms of a and b, log x of 6 would be b plus a. C, I think you'll be able to do on your own now because it's already got 2's and 3's. But let's look at 4.5. How could you write 4.5? 4.5 is 9 over 2, which is the same as 3 times 3 over 2. So then this would be log x of 3 plus log x of 3 minus log x of 2, or 2b minus a. You don't have to write any notes down because all of the notes and the explanations are done for you. You've got example 1, example 2, and example 3. I'm just going to walk through each of these so that you can see how they look and how to solve them. So up till now, we've been solving exponential equations by getting the bases the same. So as far as solving exponential equations, we have one method so far. And we used all of our exponent laws, and we solved ones like 2 to the x equals the square root or the cube root of 8 and stuff like that. And then you had to use your exponent rules and get everything to be the same base, and then you could just say, figure out the exponents that way. But there's going to be some cases where you can't get them to be the same base because they're not on your powers chart in the same column. So for example, here we've got 2, here we've got 3. Are they ever on the same powers chart? No. Can you manipulate them to be on the same powers chart? No. So now we've got to have another strategy for solving exponential equations when we can't get the bases the same. And that strategy is using the inverse, which is using logarithms. So the inverse of an exponential equation is a logarithm. And although you could solve this one just by changing it to log form, what we're going to do is we're going to develop a technique that we're always going to use. In the same way that when you're solving x squared equals 7, you would say, what's the opposite of squaring? Square rooting, and you take the square root of both sides. Here we're solving for x in an exponent. The opposite of x being an exponent is a logarithm. So when we want to get rid of x in an exponent, we can take the log of both sides. 3 looks a little high. There we go. So if I take the log of both sides, I now have log 2 of x equals log 3. Your job now is to use all of your new log laws to try to get x by itself. Do we have any log laws that we could use here? Whenever we have an exponent inside of a log, that exponent comes out in front. These questions are almost always on a calculator part of a test, and they'll ask for a certain number of decimals. So when we solve this, we're going to get log 3 divided by log 2. So we go to our calculator and we type that in. Log 3 divided by log 2. And we get 1.58. Now what I'm going to do is I'm going to store that value as x, just so that it remembers that for me. Because the nice thing about solving log equations is on your test, you will always know if you got it right or if you got it wrong. Because once you've solved it, you can check to see if it's right. What was our original equation? 2 to the x equals 3. So I can see, what is 2 to the power x? If it's equal to 3, then I know my answer is right. If it's not, I've done something wrong. So you can do a little happy dance when it's the same number, and then you know that you've got it right. So the answer is 1.58. And we've solved for x. Now this is the most basic one. But again, the strategy that we're going to use when we use logs is we're going to take the log of both sides and then use all of our log laws to try to get x by itself. There is a shortcut for this one. And the shortcut only works well if you have one of the newer calculators. But the shortcut is this. If that's exponential form, what's the log form of that? The base is 2. The answer is 3. The exponent is x. So if you can type those equations into your calculator, then you can use your definition of your logs, log 2 of 3, and get the same answer. Yes?
So with this kind of question, if it asked us to do it this way, but we had a calculator though, wouldn't it be on a the non-calculator portion?
Well, if this was asking you to solve it,
Yeah.
then you could solve it either way. They won't say by showing that you're taking log of both sides. A little bit of a disadvantage if you don't have that calculator. I've seen this on multiple choice questions, but instead, and on the multiple choice question answer, the answer was this. Natural log of 3 divided by natural log of 2. Because you have to understand that when I took the log of both sides, what I did here is I chose a log of 10, right? Because it was in my calculator. I could have taken the natural log of both sides. Then all of these places where I have log would be ln instead, and I would have got the same answer, ln 3 divided by ln 2. But on the multiple choice, that was the one that appeared. So you have to. It could be log base 7 of 3 over log base 7 of 2, if you wanted to. Okay? And this is just your change of base theorem that we learned the other day. You can change it to any base you want. Now this is the most straightforward one that you could use your definition to solve directly. These next two examples aren't like that. So there's some manipulating you could do, but again, the thing that I feel is going to be most important for you is to get used to using your log laws and get used to taking the log of both sides. Now, as you get into higher mathematics, you'll use natural log more than logarithm. And also when solving these, because you have a choice. I think in your notes I did the log of both sides, right? So for this example up here, I see that x is in the exponent. The opposite of x being in an exponent is to take the natural log. So or to take a logarithm. So I'm going to take the log of both sides, but this time I'm going to do the natural log because it's going to save me time, because every time I have to write log, I just have to write 2 letters instead of 3. Tons of time saving. So now, do I have a log law? Can I get this x out in front right away? The answer is no, because if we look at our log law for the exponent only comes out in front if that exponent is to the entire thing inside of your log. Can you see inside of that natural log that that exponent x is only to the 3, not to the 2? In fact, you can't go 2 times 3 here and make 6 because of order of operations. But we do have a multiplication happening right there. And we have a log law that says if we're multiplying, that's the same as adding. So as a first step, I can expand it. So all of those practice questions that you did where you were expanding your logs, that was setting you up for when we get to these questions for solving. And now this x is to that entire thing. So now that x can come out in front. Remember, natural log of 2, natural log of 3, natural log of 5, those are all numbers. So if you were solving for x for this normally, you wanted to get x by itself, you would subtract natural log of 2 on both sides. Then you would divide both sides by the natural log of 3. Again, we can type this into our calculator. The fraction button is helpful here. Natural log of 5 minus the natural log of 2 over the natural log of 3. Whoops. And we get 0.834. Again, I'm going to store that as x. What was my original question? My original question was 2 times 3 to the x. So 2 times 3 to the power x Does that equal 5? Yes. So we haven't made a mistake. Sorry, why is it not equal? Why isn't this equal to 1? Did you want to make this natural log of 3 on the top? You did, right? Is there a log law that says I can subtract logs and make it 3? No. The only thing, in fact, this is a good point, because if I'm subtracting logs, you could do this, because that's what subtracting logs means. But if you do anything else with logarithms that isn't one of your log laws, that's when the marking stops. So on a 4-mark question, if you make up your own log law at the beginning, that's when I'm going to stop marking that question. Even if everything else is good after that, you made that first initial mistake. Don't make up log laws. You've got 3 of them. So here, do we have a law for subtracting logs? Yes, but it's dividing. If you write natural log of 3 on the top, that's not one of our log laws. So you're going to be tempted. Oh, there's places that are going to tempt you. You're going to be tempted by this. This one's going to be very tempting. Do you know what you're going to be tempted to do? You're going to be tempted to do natural log of x plus natural log of 5. This is wrong. That's not true. But you're going to be tempted to do that. Because doesn't it look like you should be able to distribute? Right? Because you're so used to distributing. Okay? But it isn't a number. Natural log by itself, this part here, this isn't a number. This whole thing is one number. But the natural log by itself isn't a number. There is nothing you can do with, if we have just this, natural log x plus 5, we have no log laws for adding inside. You can't change this to multiplying. We only have log laws if 2 logs are added together, but not if you're adding inside. Okay? It's the same thing, right? This is not equal to this. For the same reason. Sine by itself isn't a number. It's a function. And functions aren't something that you distribute. If you have sine x plus pi over 6, the only thing you could do is this. Right? You can do sine x cos pi over 6 plus cos x sine pi over 6. Use your sum and difference identity. But you wouldn't be able to distribute. Because then you're making up math. Right? Sometimes making up math is fun. Have I showed you this? Have I showed you that? You just cancel out the ends. Oops. It works. Yes? Have I showed you that? All right. So that isn't allowed, even though it seems like it works, right? You guys know how to simplify fractions? Oh, just cancel out the 6s. That's allowed, right? It works. It's the right answer. Okay, but that is just by coincidence. Okay? These are things you're not allowed to do. So, now, if you want to play around with this one, there would be a shortcut for this one with the newer calculator. Because the shortcut which we saw here was whenever you have a single power on this side equal to a number, then you could use your definition of a logarithm. But for this one, we don't have a single power equal to a number. But if you wanted to have a little bit of fun, if you divide both sides by 2, you get 3 to the x equals 2.5. And if you would change this to the log form, log base 3 of 2.5 equals x, and you type that into your calculator, you get the same answer. Okay? I do not recommend doing this because the ones on your exam will be too complicated to do this, and then if you haven't developed the skills in working with logarithms, then you're going to really get hurt on those questions. Now, the questions that come up that are more complicated end up looking like this. So we've got 5 to the x minus 1 equals 3 to the 2x plus 3. We can't get things to be the same base. So we're going to need to take the natural log or the log of both sides. Which one would you prefer this time, log or natural log? Log? Okay. So, and don't try to do too much at one time. Don't try to do too much at one time, because if you do, you end up making a mistake, or you end up making a log, up a new log law, and then the marking stops. So when you take the log of both sides, just start with that. Okay? Is this exponent to the entire thing? Yes. So it can come out in front. And when it comes out in front here, because there was more than one thing, we'd have to put it in brackets. Same thing here, the 2x plus 3 could come out in front. Is log 5 a number? Right, it is. Notice log by itself isn't a number, but this whole thing, log 5, is a number. And because it's a number, it can be distributed. So what am I going to get on this side? I'm going to get x log 5 minus log 5. We should have chose natural logs. Look how much time we would have saved already. On this other side, log 3 is a number, so it can get distributed. So we're going to get 2x log 3 plus 3 log 3. Now in solving for x, what makes this one a little bit more difficult is you see that there's x's on both sides. Okay? What would you do, just going to go off this page for a second, what would you do if it was easier numbers? If you had 3 plus 5x equals 7x minus 8. Let's go back to grade 9. If you have x's on both sides and you have numbers on both sides, what would you do? You put the x's on one side and the numbers on the other side. So we're going to do that even though the values that we have aren't conducive to putting together. But I'm going to put my x's on one side, so I'm going to subtract 2x log 3. I'm going to put my numbers, which is 3 log 3, and I'm going to add log 5. So my numbers are on one side, my x's are on another side. Now, when you did that on this equation, you would get 5x minus 7x and negative 8 minus 3. The difference is, in this question, you could put these together, right? Okay? Because they're nice numbers. In our question, we can't put them together because they're not nice numbers. And unless you want to go to your calculator and remember like 18 decimal places, because you're not allowed to round to like the end of a question, this gets messy. So instead of putting these together, How could I get x by itself in these two? I could factor out the x. That would leave me with log 5 minus 2 log 3. And I still have 3 log 3. You can see why I said it's nice to save a little bit of time and use natural logs. Look how many letters we would have saved already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters already, just in this part. And then how would you get x by itself? Divide. So we have 3 log 3 plus log 5 on top, and we're dividing by log 5 minus 2 log 3. Again, this is where it's really nice to have the fraction button on your calculator. So we had 3 log 3 plus log 5 on top divided by log 5 minus 2 log 3. Log 5 minus 2 log 3. Okay? That is a little busy, isn't it? So we push enter, and we get negative 8.34. I'm going to store that as x. The store button is right above your on button. And then you just hit store and it automatically takes your answer. And then you can choose any letter if you don't like using x. If you like to use, you know, I could have stored this as alpha C if C is your favorite letter. And then it would store it as C. X is just quickest to use, so that's why I like to use it the most. So now we've got an answer. If you want to find out if you were right, you go back to your original equation. In our original equation, on the left side, we had 5 to the power x plus 1. Put that in and see what it equals. On the right side of our equation, we had 3 to the power 2x plus 3. If these numbers are different, we made a mistake. 5x minus 1. Oh, I wrote 5x plus 1. Now, oh, I know. Right now, like my palms are sweating. I don't know if I want to push enter. Oh, they're the same. So we haven't made any mistakes. So because of the same, our value of x, which was negative 8.34, is correct. No, that was when we checked. So if we go back to our calculator, the x value is negative 8.34. But when we checked it, we had times 10 to the negative 7 for both of them. So this is probably the most important part of the log unit. Using all of our log laws and understanding what a logarithm is to be able to solve exponential equations. Again, when solving exponential equations, you will have to decide whether you're going to use logarithms or whether you're going to try to get the bases the same. Generally speaking, they will ask this type getting the bases the same when you have non-calculator. So our first quiz, I think I had 10 questions on there that were like that, on that first take-home quiz, where you had to rearrange them to get the bases the same. That's because those would be non-calculator questions. If they're calculator questions, you probably can't get the bases the same, then it makes sense to use your logarithms. And if you can't get the bases the same, start by taking the log of both sides. Then you're going to need to use your log laws to get x by itself. And the most complicated ones are when there's x's on both sides, and then you have to remember to get 1x by itself at this step right here. We had to factor. So we're going to take maybe 10, 15 minutes now On the back of that quick review of log laws, exercise number 1, there is a whole bunch of them there for you to solve. Each one you solve for using logarithms or the change of base, or getting the bases the same. And if you want to know if your answer is right, you have to plug it back in. So it's training you to check by plugging your answer back in. All of those ones are going to be calculated. Okay?